Today we're writing quadratic equations. We're going to take exactly what we learned yesterday and just apply it towards, you know, I mean, if you want to call them upper level problems, but they really are no more difficult than anything you've done yesterday. We are writing quadratic equations. Here are the roots, R1 and R2. Okay, first of all, tell me about those roots. What do you know about them? They are, yeah, they're conjugates of each other. The roots are imaginary. Now, we got to somehow build back the quadratic equation that made these roots. We're going to take two formulas that we learned yesterday. We're going to take the idea that the sum of the roots, R1 plus R2, right? What's the sum of the roots equal to? The sum of the roots is equal to negative b over a. I'm just writing it like this so you understand. The sum of the roots. What is 3 plus I plus 3 minus I? Let's see. That's 3 plus I plus 3 minus I equals negative b over a. And so what? I mean, the i's cancel away, and so 6 equals negative b over a. Which means, how much is b? Right? B, right. B therefore has to equal negative 6, because negative 6 is 6. And how much is a? Good. Ah, we got two of the three letters that we need. We got A, B, and now we just got to go looking for C. All right, now we got to go find that third one. We got to find out how much C is, right? What's the other formula I taught you yesterday? Yeah, the product of the roots. The product of the roots, R1 times R2 equals C over A. We already know how much A is. We're going to fill it in a minute, right? The roots, that's 3 plus I times 3 minus I equals C over A. You know, that's really easy in a calculator, right? We could just plug it in. Maybe, what's up? Maybe we should do it out. Let's try and just do it really fast in our heads, okay? 3 times 3, 3 times negative I. How much is 3 times 3? 3 times negative I is minus 3i. How much I times 3? Plus 3i. What about I times I? Remember that? And I squared is how much? No. I squared is negative 1. So this is negative 1 equals C over A. Yeah? These guys are destroyed. Negative 1 is how much? Is plus 1. And 9 plus 1 is how much? So 10 equals C over A. And we already know A is 1, so how much is C? Yeah, C is equal to 10. Right? There's that one. Whoops. Okay. So I only bubbled in these letters because this is important stuff. Let me go big screen for a second, right? Let me go big screen for a second. So here we go. A is 1, B is negative 6, C is 10. What's the equation I'm looking for? 1x squared. Now how much was B? Minus 6x. How much was C? Plus 10. That's the final answer that I'm looking for. Okay? Is that hard? Okay. So we're going to do question number 8. I know it's written perhaps maybe a little bit differently on your sheet of paper, but essentially that's just what it's asking. Right? Build for me a quadratic equation that has the sum of its roots equal to 3 and the product of its roots equal to negative 4. All right. Let's do this. Let's do this. The sum of the roots equals 3, which means that 3 equals what formula? Okay, let's just write the stuff down that we know. We also know that the product of the roots equals -4. So what does -4 equal? Okay, so flat off the bat, you can always do this. -4 is the same thing as 4 over 1, and 3 is the same thing as 3 over 1. So right off the bat, we got A. And what else did we get? Yeah, we got A and we got C off this one. A equals 1, C equals -4. Now let's see, how much is B? Now B is the tricky one because it has that negative in front. How much is B? Yeah, B is -3. Are we done? Oh. What's it asking for, right? We want the formula. So we're looking for the formula that's 1x squared minus 3x minus 4. Nope, just that. Oh, yeah, we should write equals 0. But sorry about that. We should write equals 0. It is important because the roots are where it hits the x-axis, and that's where it equals 0. So all these equations, when we ask for the roots, are where it equals 0. We should have done that in our other problem. Let's go and fix that. Would I take points off? No. No. On the Regents exam, would they take points off? It's questionable. It's questionable. It's not like one of those definitive, definite things. But let's do this. Let's do this for the time being. All I did was add that on. Maybe you want to add it onto your paper.
I just want to make a shout out to my mom first before we start. Hi, Mom. So at first they gave you this. So then you found out this. 5 over 8. So then you found out A equals A and -B equals 5. So that means B equals -5. Then you got to sub this in. So you know A equals 8. And you got to multiply that by 2 to make it so it equals 2, right? Yeah, so then you found out C is 16. And you sub it into the equation. And you get this. Thank you. Jamel. I'm a boss. My work here is done. I love you, Mommy.
So here we go. Now we're going to start dealing with things that are a little bit more complicated, but it's the same ideas, right? First of all, we're going to find the sum. Bless you. What's the sum of the roots? The sum of the roots is simply, as its name suggests, R1 plus R2. Yeah, part A, because we're in 36. R1 plus R2. How much is a third plus 3/2? Ooh, that's terrible, right? That's terrible. You can only add or subtract two fractions when they have the same whats? Denominators. What's the common denominators for these two? Yeah, so it's like this one we'd multiply by 3 over 3, and this one we multiply by 2 over 2. You could put it in your calculator, but as they suggested at my meeting yesterday, I should be working more on like just the basic math stuff. That's all we're doing. Plus 9 over 6, right? But if you're really uncomfortable, of course you can use your calculator. What's 2/6 plus 9/6? 11/6. Look how good you guys are at this. You don't need a calculator. Talk. Let's talk. The product of the roots, right? The product of the roots is a third times 3 over 2. Yeah, because when you multiply two fractions, it's top times top and bottom times bottom. So that's 3 over 6, and that's a half. There we go. There we go. So that's part B. We found the sum of the roots by hand. We found the product of the roots by hand. We could have plugged these into the calculator, but I think it makes a lot more sense doing it this way. I like not using a calculator. And now, right, it does make you smarter. And now, we're going to build the equation, then we're calling it quits for the day. So we're trying to build back that equation. The only way to build the equation is to use this idea of the sum of the roots and the product of the roots. The sum of the roots being negative b over a, the product of the roots being c over a. And as you can see, the a's do not agree in any of the cases. The only thing that you absolutely know for sure is which number.
C.
Yes. The only one that you know for sure is this one. B, and B has to be what? That's it. I mean, even still that you don't know necessarily for sure. It could be lots of things, but it's the easiest one really to pick out. B has to be negative 11. Now, this does not bode well, right? You have to get these to match somehow. Here it is, you have A equal to 6, and over here you have C over A equaling a half. So if A happens to be 6, what does C have to be?
3.
No. Oh, yes, 3. You're right. C has to equal 3, and A equals 6, right? That'll work. 3 over 6 is a half. And over here, we've got A also equal to 6. Yeah, negative 11 is 11, and A is 6. Nice. So here we go, right? All we're going to do is fill it in. You're going to get 6x squared minus 11x plus 3 equals 0, and that's our final answer.